my Restructured Module 5 video on functions under composition. So here we're given the function v of x is equal to 2x cubed minus 7 because we love the properties of addition and multiplication and not so much the properties of subtraction and division because they are commutative and they are associative. Well, addition and multiplication are. I've gone ahead and rewritten this function as 2x cubed plus negative 7, so that way we were only working with multiplication and addition. So now the first step into creating the inverse function, which we are going to end up calling z of x, is that we want to think about our order of operations, our PEMDAS. Please excuse my dear Aunt Sally. We want to think about what operations are happening in our original problem. Well, we have an exponent. We also have multiplication happening with our 2, and we also have addition, at least in our rewritten problem, of adding negative 7. So now I want to think about the order that we are doing these operations in. So for our original function, v of x, our first thing that we're going to do is we are going to use deal with our exponents. So for original function, we are raising x to the power of 3, which I'm going to write as raising to the power of 3 over 1. Our second step is that we are dealing with our multiplication. So in our original problem, we are multiplying by 2, which I'm going to rewrite as multiplying by 2 over 1. And our last step is that we are dealing with addition. We are adding negative 7. So for our new or our inverse function, which we are calling z of x, we want to do the inverse of our original operations in reverse order. So we want to do the inverse of each of these steps working backwards. So the first thing that we are going to be doing for our inverse function will be the inverse of our last step. So the inverse of adding negative 7 is adding positive 7, which is just adding 7. The second step will be the inverse of our second step here. Let me just kind of deal with these as I mark them as I go. So the inverse of multiplying by 2 over 1 is multiplying by 1 over 2, or its reciprocal. And our third step will be doing the inverse of our first step. So the inverse of taking something to the power of 3 or cubing it would be taking something to the power of 3 over 1, which is the inverse. So to write our inverse function, z of x, the first thing that, again, we're going to want to do is we're going to add 7 to our x. We're going to take x, we're going to add 7 to it. And I'm going to make sure that this is the first thing that we're going to do by putting parentheses around that, because parentheses signify priority. The second thing that we're going to do is we're going to take that whole thing and we are going to multiply it by 1/2. That will take care of our second step. And then our last step, we are going to take that whole thing, and here I'm using brackets, but we're still using our grouping symbols. We're going to take that and put everything to the power of 1/3, and that would be our last step. So on the second page, because composition of functions is commutative, we can compose z of x and v of x both ways, and we should end up with our identity function x, which you'll see at the bottom. So here you can see that I did v of z of x, and once you plug in the z function into your v function, we end up with some 1 pairs, right? 1/3 times 3 over 1 gives us a 1 pair because of our multiplicative identity, and that no longer adds value to our function, so I just drew 2 giant 1s through the 1 pairs that are created, 3 over 3 and 1 over 1. Again, we have another set of 1 pairs, 2 over 1 times 1 over 2 creates a 1 pair, which no longer adds value to our problem. And then at the bottom we have a giant 0 pair, positive 7 plus negative 7, which creates a 0 pair because of our additive identity. And ultimately we end up with x. Here we have z of v of x, and I highlighted in yellow where I put v of x into z of x. And then here we start off with our 0 pair. Our negative 7 plus 7 gives us a 0 pair due to our additive identity. And then here in our third step, we end up with another set of 1 pairs. And in our fourth step, we end up with another set of 1 pairs, 3 over 1 to the power of 1/3, which gives us a 1 pair. And we end up with x to the power of 1, which is just x. So again, we end up with our identity function, which is f of x equals x. And then on the last page, I just did a visual. I graphed these three functions, the identity property f of x equals x, and both v of x and z of x. And as you can see, v of x and z of x are reflections of each other over the identity function, which is the red line. And that visually proves that these two functions are in fact inverses of each other.